This lesson is on rational exponents. Rational exponents are just fractional exponents. It's another way of expressing radicals. You can express all radicals as rational exponents, fractional exponents. For that reason, you should never have fractional exponents or rational exponents in the denominator. You cannot divide something by something else that never ends, and radicals or irrational numbers that never end. So we can interchange the way we interchange from radical form to fractional exponents is we take the index, the base of the exponent in the under the radical sign. It stays as the base of the exponent. So a is the base of the exponent under the radical sign. It will still be the base of the exponent. The index becomes the denominator of the fractional exponent, and the y becomes the numerator of the fractional exponent. For example, this cube root of 4, we can rewrite the 4 as 2 squared. So to change that from radical form to exponential form, we would still keep 2 as the base, and then 3 would go in the denominator of the fractional exponent, and the 2 would go in the numerator. X to the 4/3 power, if we wanted to change that to radical form, we would keep x up under the radical sign. That's still going to be the base of our exponent in the radicand. The 3 in the denominator will become the index of our radical, and the 4 in the numerator will be the exponent for our radicand. Remember, anytime the exponent has an even number in the numerator, the value of the base can be either positive or negative. So you'll likely get 2 solutions whenever the numerator of the fractional exponent is an even number. All right, first example. First thing I would suggest that you do is do a factor tree so that you can write the numbers as exponents. So if we factor 243, well, what I did first was I just did the opposite of raising something to the 5/4 power, which is raising it to the 4/5 power. Those two, whenever we multiply those exponents, are going to cancel on the left side. Where we do to one side, we have to do to the other side. And then I did a factor tree for 243. So I can rewrite the 243 as 3 to the 5th power. So whenever I raise both sides to the 4/5 power, I'll just get m on the left side. And then when I raise 3/5 to the 4/5 power, the 5s will cancel, leaving me with 3 to the 4th power. 3 to the 4th power is just 81. Next, let's go ahead and factor 729. So I can, instead of writing 729, I can write that as 3 to the 6th power. And the opposite of raising something to the 3/2 power is raising it to the 2/3 power. So I'm going to raise both sides to the 2/3 power. And 3 will divide into that 6 2 times. 2 times 2 is 4. So I'll have 3 to the 4th power on the left side, and just x on the right side. 3 to the 4th power is 81 again. Next example, I want to factor that 1080, or we could divide both sides by 5 first. That's going to give us n to the 3/2 equals 216. Do a factor tree. I can write instead for that 216, I can write that as 2 to the 3rd power, 3 to the 3rd power. And then raise both sides to the, since n is raised to the 3/2 power, we want to do the opposite and raise both sides to the 2/3 power. That'll leave us with just n on the left side. Whenever the 2/3, 2 to the 3rd power raised to the 2/3 power, the 3's will cancel, leaving me with 2 squared. and then 3 cubed raised to the 2/3 power. The 3's will cancel, leaving you with 3 squared. 2 squared is 4. 3 squared is 9. 9 times 4 is 36. Alright, first thing we want to do here is go ahead and multiply both sides by -1. That's going to give us 16 equals 52 minus 2b raised to the 4/3 power. Alright, now notice that 16 is just 2 to the 4th power, but we have in that fractional exponent, the numerator is even. That tells us that we're going to have 2 solutions. So 16 is 2 to the 4th power. And then now, whenever I raise both sides to the reciprocal of 4/3, which is 3/4, I'm going to have 2 results. Whenever I raise the left side to the 3/4 power, the 4's will cancel, leaving me with 2 cubed equals 52 minus 2v. And then notice, since that numerator for the fractional exponent is even, there's 2 possible values for that base of that exponent. It could be positive 52 minus 2v. It could also be negative 52 minus 2v. So we'll do that one second. 2 cubed is 8. Subtract 52 from both sides. Get negative 44. Divide both sides by -2. v equals 22. And again, we can have for that, whenever you have a positive exponent, that base could be either positive or negative, because whenever you square or raise something to an even power, that base, whether it's positive or negative, it's always going to give you a positive result. So we want to do the same thing except for negating the base of the exponent that had a even number in the numerator. So I negated the 52 minus 2v to get negative 52 plus 2v. 2 cubed is still 8. Add 52 to both sides. Divide both sides by 2. The other possible value for v is 30. So v can be 22 or 30. Alright, next example, we want to start by adding 8 to both sides. And then we want to divide both sides by 2. And then we want to do the opposite of raising the left side to the 3/2 power, which is raise it to the 2/3 power. We want to factor the 729. You can, instead of writing 729, we can write 3 to the 6th power. And whenever we raise 3 to the 6th power to the 2/3 power, 3 divides into 6 2 times. 2 times 2 is 4. So we have 3 to the 4th power on the right side. And the exponents cancel on the left side. 3 to the 4th power is 81. Subtract 2 from both sides. N equals 79. And this next example, we want to start by adding 6 to both sides. And then we're going to multiply both sides by -1. We're going to raise both sides to the 5/4 power, and in place of the 16, we're going to put 2 to the 4th power. Now notice the fractional exponent has an even numerator, so there's going to be 2 possible values for the base, a positive and a negative. Alright, so we're going to have 7 minus n raised, once those exponents will cancel, and then 2 to the 4th power raised to the 5th power. The 4's will cancel, leaving us with 2 to the 5th power. So we have 7 minus n equals 2 to the 5th. 2 to the 5th is 32. Subtract 7. So n is going to be -25. And then now that we just did the positive value for the base, now we want to do the negative value for the base, since that numerator for the fractional exponent was even. So we want to change the sign of everything in the base. Alright, so whenever we change the sign of the base, we get -7 plus n equals 2 to the 5th. 2 to the 5th is 32. Add 7 to both sides, and we get n also could equal 39.